Hello guys, welcome you all for this end-to-end session of AML, DL, computer vision, NLP, Gen AI, everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot and we are learning a lot each and every day. Hope the same thing for you guys. So, and one more thing guys, if you are come to this session, as always, please make sure you guys watch all the previous session videos so that you can have a better understanding of what we're going to talk. Okay. So, and one more thing guys, we are having 2000 plus quizzes in our YouTube channel. Please go and just attempt it. Give an attempt. Okay, we doesn't need a right answer. Just go and have an attempt. Okay. So and one more thing, like guys, if you're to this level, please make sure you guys subscribe to our channel, because like every day we are just posting a new video. So please subscribe to our channel and press the bell icon so that you will be getting notification whenever we are just uploading a new video. Okay. So and adding on, we are dived into a new world called as deep learning, right? We have completed playing with data, we have completed playing with machine learning. Now we have started to play with deep learning, and we have completed playing with one of the algorithm of deep learning, that is AINL. We have completed the coding part also. Okay. So keeping apart, like last session, we have introduced you what is CNN, what is our background of everything. Okay. Today we're gonna continue that. So that's the reason we have asked you guys just look into all the previous session. At least for this session, make sure you guys watch the previous session so that it will be the continuation of previous session. Okay. So let us understand. Today we're gonna continue with CNN, whose applications. Okay. Image classification, identifying objects in an image such as cars, animals, or people. CNN helps to do for go for the image classification. Object detection, locating and identifying objects within an image, providing boundary box and labels. Okay, it is like a detection kind of thing. Instead of classification, consider what is image classification and detection. What is the difference between them? Image classification means, consider this is a frame. This is the entire frame. Okay, if it is an image classification, it's gonna call it as human, because I'm a human, right? Okay. If it is an object detection, let us consider there is a watch in my hand. What it will do means, okay, it will create a boundary box, like a rectangular box, and it will say it is a watch. So like that, it will locate where is an object and also the boundary box, that is called as object detection in the image. Okay, image classification is completely different. Image object detection is completely different. Both are applications of CNN. And medical imaging, yeah, analyzing medical images such as X-ray, CT scan, and MRI to assist in diagnosing and treating the planning. Okay, medical field. You guys can understand, right? X-rays. We will be having lots of X-rays, different kinds of X-rays, TC scan, MRI. There is something called as I recently worked on a project which is like the brain waves, right? Those are like applications of medical medicine where we will be using the same. Okay. Natural language processing, yeah, it processes the text and speech data, enabling tasks such as sentiment analysis and machine learning transaction very easier. Okay. This also I worked on a project where we will be creating a text to speech to text. Okay, where we will be creating like a kind of an image that is called as the spectrogram. Okay, out of the whatever the speech we do, whatever we speak, it will we will create an image kind of thing that is called as a spectrogram for a speech. For example, I'm going to temple. This is a speech. For this speech, there will be a spectrogram. Kind of consider it is an image. Okay, so from that image we will be converting that image to a text. So that kind of operation we can do by using CNN. Okay, so these are some of the applications. Multiple and any number of applications are available, because as always this slide can accommodate only 4 things, so I have just mentioned. So anything, everything that has an image, we have an application for this CNN. Okay, so yeah sir, over to you. Anything that you want to share, sir?
Yeah. Okay.
Yeah.
So welcome, guys. If you've come to this session, just go back and watch all the previous sessions end to end 5 to 10 times. Do reinforced learning with the long-term objective function of your career objective function, I'll call, uh, and a lifelong learning mindset with elements of patience, persistency, consistency, and perseverance. So I can see like we are losing these days tolerance and patience. So that is the only thing which is going to help you guys to become an expert in particular field. So these skills, even they are going to help you in your life. So let's come to this particular. So subscribe to our channels, also press the bell icon so that we will get notification, and do all the quizzes, all the projects, all the assignments 360-degree, and understand all the concept, what and why, and then do all the projects, assignments, and understand how, and absorb the information, digest and apply. So this is the pedagogy, and this is the method, and this is the simplest method. So let's dive into this particular session. Application of CNNs in data science, AIML. So image classification is first element. It identifies the objects in the image such as cars, animals, or people. So that is very important in image classification in CNN. It is very object detection again. This is the application we can apply: locating, identifying objects within an image, providing boundaries, boxes, and the labels. Exactly. Like there is a science behind that also. We'll go deep into that. So it will do that. Again, modeling, imaging, and analyzing medical imaging such as X-rays, CT scans, MRAs to assess diagnosis and treatment planning. So this is how CNNs can be applied into different industries, into healthcare, into finance, into computer vision, into other lot of like into a lot of aspects, lot of industries we can. Then again, we can apply into. I was designing a course on like generative AI for supply chain management. So I understood deeply that NLP we use a lot because there's a lot of tracking, lot of contracts, lot of things, lot of documentation, and immensely we can use. So again here NLP processing, it helps us text and speech data, enabling tasks such as sentiment analysis, machine transaction. Again, there I got one idea that sentiment analysis is done so that you understand what customers are saying and you plan, and so that disruption should not happen in the industry or somebody else like as a competitor in your. So you can use these deep technologies to be relevant in all times. So these are the applications. Let's move to the other section.
Yeah, sure, sir. So, guys, these are the applications. Okay, are not limited to this. We are having a number of applications. So, as I mentioned, wherever there is an image, we're gonna have an application for CNN. Okay, let's move to the next slide. Okay, preparing data for CNN, guys. This is a major thing. Okay, actually, from the first class itself, we are just explaining you. You guys need to prepare data, like go for EDA, collection of data, everything, right? What's the reason means once you have a data ready, you are having a legitimate data, then everything else is fine. Everything else is very easier for you. Okay, let's understand how to prepare a data for CNN models. Okay, data collection: gather a large and diverse data set of images relevant to the task. For example, our task is to classify cat and dog, so we need to collect large volume of data set of images of cats and dogs. Okay, it should be like different orientation, different colors, different shape, different size, everything. Okay, data pre-processing: cleaning and transforming the data, resizing images, normalizing pixel values, and augmenting the data. So once we collect the data can be like not can be as we need it, right? It can be black and white, it can be color, so we need to make everything in a single scale so that we can apply to the model. Data augmentation, I hope like this is one of the pre-processing step you guys can see here, right? It comes under the pre-processing, but like it's a separate pre-processing step. Data augmentation: enriching the data by creating a new images through techniques called as rotation, flipping, and cropping. Okay, consider we are having a cat image. Okay, a state cat image. When we go for a 90-degree rotation, it will be like this, right? This is also cat. If it is go for 180, it will be like something like this. Okay, so any angle it is cat, if it is a cat. Okay, for something like flipping, we can flip left right like those, and then we can crop only cat's image, cat's head. Instead of entire cat image, we can go for only cat head, like that. We can go for data augmentation, that is creating new images, sorry, getting new images from the parts of the already existing images, that is called as data augmentation. Data splitting, we need to divide the data into training, validation, testing for the model training and evaluation. You guys know about it. Okay, if you guys doesn't know, please make sure you guys watch the first session of machine learning coding part. Okay, where we have explained why we need the training, validation, and testing. I will explain the gist of it. Training data, where we use those data for training the model. While training and completion of each and every epoch, we use the validation data to validate whether the model is trained perfectly in that epoch or not. Finally, you have a trained model and you will be testing with the data which is unseen by the model. That is called as test itself. Okay. I hope like these are the pre-processing techniques. Hope you guys are able to understand. Yes, sir. Over to you.
Yeah, so preparing data for CNN models, data collection is very important. Collecting data as per the problem statement, objective function, and um, what you are going to solve and whatever, and problem statement, and then you have to collect it from the right source, okay, and with ethics and integrity, gathering large and diverse data set images relevant to the task, okay. Then data pre-processing, cleaning, transforming the data, okay, resizing images, normalizing pixel values and augmented data. So then we do data augmentation, enriching the data by creating new image through techniques like rotation, flipping, cropping. Then we have to go data splitting, dividing data into training and validation, and test sets for the model training and evaluation. So these are the processes, you know, that in other uh, ways we collect the numbers and different data, like for machine learning and all. But here, when we go for CNN images, so we here the data is images, guys. Somewhere in computer vision, it would be videos, something, some other. Again, videos are same, they are generated from pictures only. So videos are nothing, they are just moving pictures, okay, frames. So these are the elements. So let's go to the other section, learn deeply with long-term objective function as a lifelong learner, and keep learning deeply. We are learning deep learning, guys. Now we are in depth for search. You are becoming specialized person, data scientist, AIML researcher, or AI scientist. So keep learning deeply, guys. Let's move to the other side.
Yeah, sure, sir. Let's move on to the next thing. Training and evaluating the CNN model. Okay, once we have collected the data, that is every prerequisite is completed. Now let us consider how to train and evaluate our CNN model. Training, feeding the training data to CNN and adjusting the weight to minimize the error. I hope like you guys already know about it. What is my weight adjustment? Once consider the output of an image is cat, but it is giving something like dog. So we will go for a back propagation and it will do the training and it will come back, and if it is again it will say something different, then we'll go back and come back, update the weights and come back to predict the things, unless and until it's gonna mention the cat image as cat, dog image as dog. So like that, that is what training. Validation, we are evaluating the model's performance on a separate validation set to monitor its regularization, generalization ability. Okay, once a epoch is completed, the once one learning is completed, we will use the validation data to validate the model. Testing data, like testing, evaluating the trained model on a previously unseen test set to assess its final performance. Okay, this data which is unseen by the model, so that it will be used to test the model's performance. Okay, guys, I'm repeating again. This was I have discussed in the previous slide itself. Let us discuss this completely because you guys need to have a 100% idea of what it is. Training data using which we will train the model. So, for example, we are training the model for 10 epoch. 10 epoch means you're gonna learn like learning the book. Okay, You are learning the book start to end one time, start to end second time, start to end third time, start to end fourth time. Like that, you are going for 10 epoch. So when one epoch is completed, training, learning is completed, we use a validation data to check whether the model learned properly or not. Then go for the second epoch. Like that, if we keep on go, at the end of each and every epoch, we will be giving the validation data to validate our model. Testing data which is unseen by the model. Once 10 step is completed, we have a model which have learned all the data whichever we given in the training data. So we will give the test data. So the model will predict the result. So the test data will be unseen by the model during its training phase. Okay, and the test data is called as unseen data. Okay, so this is what all about this training, validation, and testing. Okay, yes, sir, over to you.
Yes, so training and evaluation CNN models, training, feeding the training data to the CNN model, adjusting its weights to minimizing the error. So we have to do adjustments in the weights. Okay, so you guys know what are weights. Okay, they're just numbers assigned to the particular. So because see, machines learn in numeric, or you cannot teach them the sentiments and the how human beings think. Still the time we have quantum computers, so they will understand binary and numbers only, and ultimately they actually understand by binary, but in numbers we give them, and so we assign weights to it. So that's what we call weights. So validation, evaluating the model's performance on the separate validation set to monitor its generalization again. The that should be like your model should be generalizing, it should have generalizing ability, so that then it will learn. Okay, if somebody is like, I'll give you example, if somebody says I can't learn anything, still that's a problem. If somebody says I don't want to learn because I've learned enough, so it's underfit, overfit, right? So you need a model which says I have learned something, I will keep learning more continuously. That is what the model we need. We need a model which learns from the data when it is applied in the real life. That is the actual essence of generalizability. Again, we also do that, guys. We do all the time generalization. If you see any human being, we are specialized, but certain things we do generalization. We keep learning. Okay, we start with that. So, testing, evaluating the trained model on the previous unseen data to see, assess the final performance. So again, testing is like you evaluate the models, train the model on previous unseen data, whatever was not seen. So you do that and then assess the final performance. This is what is training and evaluating CNN models, which is the same concept what we have learned in the machine learning, but here it is just we are doing with CNN. That's it. The concept, basic concept is same. You do training and evaluation there also, you do here also, but here algorithm will be different and data might be computer pictures and videos something, or for NLP it will be text something. Okay, and that this is how we learn deeply. So let's go to the other section.
Yeah, sure, sir. So, guys, moving on. Let us understand what are the challenges and limitations of CNN. Okay, we till now we have discussed what are the all the importance, all the features that the CNN can provide. Let us understand its challenges and limitations. First is computational resources. CNNs can be computationally demanding, requiring significant processing powers and memory. Okay, as we are mentioning, right? We gonna play with image. To train the image, we need computation. That is the kind of a GPU. Data requirements. CNN requires a large volume of data, large volumes of labeled data effectively training for effective training, because deep learning model gonna extract the feature by itself, right? So we need this data requirement, large volume of data. Okay, then interoperability, it can be difficult to understand the reasoning behind CNN's decision, making them less transparency. Yeah, true. In CNN, we will be creating a model. You guys gonna play with the coding in next session. I will show that, but you guys doesn't know what internally occurring. So we need to have interoperability, but which is not present in. So in the CNN, one of the limitations considered as interoperability. Robustness, CNN can be like uh, susceptible to adversarial examples, which are inputs designed to mislead the model. Okay, we doesn't have a like secured CNN. Okay, so we need to build it. So but so that we can get the model which is robust. So these four are some of the challenges and limitations are present in CNN. Like computational resources are high, data requirements is very high, interoperability is very low, robustness which is like it's a question. Okay, so yeah, so these are some of the challenges and limitations of CNN. So yeah guys, that's it. If you guys have any doubt, just speak in the comment section, we'll take up and we'll solve your doubts. Okay, so yeah, this is all about the challenges and limitations of CNN. Yes sir, over to you.
Yeah, challenges and limitations of CNN, guys. Computational resources, it's one of the, I'll say, main thing one has to have, because for image, videos, all these texts, when you're building like uh, great application, you need to train it from scratch, and you have to train the model. And competition, like it requires high, it's significant, right? You need to use memory, processing power. Is very, very important. Data requirements, CNN requires large amount of labeled data for effective training. Okay, so if you see Chat GPT, it is trained on billions of data sets, guys. Then and only you are getting this much of output. And for that, OpenAI was non for profit, but then they needed, so they connected with Microsoft, and they gave funding, and also they gave the servers computational power to ChatGPT, and then it became a big company. Like that is years of hard work. There was one GPT, one, two, three. Okay, now you have four. So it's been like over the 3 4 years, I can see 3 4 5 years, it's, I think they have been training only that model, understand. So this, you need a huge computation. And then interpretability, it can be difficult for understanding reasoning behind CNN decision making. Okay, so robustness, CNN can be uh, susceptible to adversarial examples, which are input designed to mislead. So these are the challenges, and input designed to mislead the model. Okay, then you have there are challenges, there are limitations. So these are the four limitations, major limitations. Let's go to the other session. Thanks.
Yeah guys, so I hope like you guys are able to understand the black box behind the CNN, because like the next section we're gonna see the coding part of CNN. Hope you guys have enjoyed. We have enjoyed a lot and we have learned a lot. Hope the same thing for you guys. If you guys like come to this session, like it's incredible guys, because like it's nearly 150 plus sessions we are done. So if you guys are following till this step, we are just appreciating your patience and the dedication guys. Okay, it's really appreciable. Okay, so before signing it off, I want two things from you. Please make sure you guys subscribe to the channel so that we can get whenever a new video is posted, you can get the uh, notification from whenever a new video is turned out in our YouTube channel. And one more thing, there are 2000 plus quizzes which are available in our YouTube channel. Please make sure you guys go there and just attend it. Okay, it can be right or wrong. Okay, so yeah, that's it about today's session, guys. Today's session is a continuation of previous session where we have talked about the theory concepts of CNN. Okay, so until next session, bye guys. Take care. We will all meet in the next session. Bye guys.